Hello everyone. In this video, we will be solving system of inequalities by graphing. This is the second part. I will put the link of the first part in the description box below. Before we look into this example that we have here, let's have a review on graphing inequalities in two variables. We remember that if we have a greater than or equal to or less than or equal to, we are going to use the solid graph. And if we have a greater than or less than, we're going to use the broken graph. Now let's look at the first example right here. So we have an equation y is less than equal to 2 over 3x plus 4. So this is a line. And the other one is y is greater than x plus 3 squared minus 5. So we're going to graph the first one here. We have, we determine the slope for this. So our m is 2 over 3. And then our b is 4. Now we remember that slope represents this. So it's gonna be the numerator would tell us where to go up or down, and then the denominator will tell us where to go left or right. So we are going to plug the y-intercept, so that would be on 4. So this is gonna be right here. So that's the first dot. That's gonna be the y-intercept 4, and then it says that the slope is 2 over 3, and they're all positive. So we can go ahead and say we go up because it's positive. So this would be up. And then 3, since it's positive, we go to the right. So we go up to 1, 2. We go to the right 3, 1, 2, 3. So this is where the second dot is. Now we are ready to graph this. Now we remember that if we graph this, if there's a bar underneath, we're going to use a solid line. So I'm going to use a solid line for this. The solution part, now we remember that we have two choices from the y-intercept. It's either we shade above it or we shade below it. The trick is, if y is isolated by itself on the left side, locate the vertex, and from the vertex, shade above the vertex if it's greater than or equal to, shade below the vertex if it's less than or equal to. Since this is less than or equal to, we are going to shade below the vertex. So below this point will be the one that we shade. So I'm just going to shade this part below this point. This means that the solution for this inequality are the ones that are below this line. Now let's have the second graph right here. So we have this one right here is a parabola. We determine the vertex first. So from here, we can go ahead and say that the vertex is, remember, we switch and keep. So that would be on -3 and -5. So then we can go ahead and write the vertex on -3, -5. So that's 1, 2, 3. And then we go down -5. That's 1, 2, 3, 4, 5. So this is where the vertex of the parabola is. To determine the rest of the dots, we're supposed to create the table. Before we look into creating the table, we remember I give you a trick. We are going to cover the H and the K, and then we change the inequality to equal sign, and then we use that equation to determine the rest of the dots. So the equation that we're going to use would be y is equal to, I'm just going to show the work here, y is equal to x squared. So then we create the table from the vertex. So I created the table. So from the vertex, we are going to move one step to the right. But the problem is, where do we go? Up or down? So to determine where do we go after that, we're going to use this equation right here. So just like how we did in the previous video, we're going to plug this 1 into the x. So that would be this 1, 2, and 3 will be plugged into the x. So that's going to be 1 squared is just 1. So since it's positive, so we go up. And then 2 squared would be 4, so that means we go up 4. And then the 3 squared would be 9, so we go up 9, which means that if we sketch the rest of the dots, that would be we go 1 step to the right and 1 step up. So this is the second dot. 2 steps to the right from the vertex, so that's what it says, from the vertex. 1, 2, then we go up 4. 1, 2, 3, 4. So this is where the dot is gonna sit. And 3 right from the vertex. 1, 2, 3. Then we go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's gonna sit here. So then we go ahead and reflect it across to create the parabola. Okay, so we're ready to sketch the graph. Now we remember that since there is no bar underneath, we are going to use a broken graph. So it's going to be a broken graph. And so we can sketch the broken graph right here. Okay, so we are going to shade the parts. It's either above the vertex or below the vertex. Again, the trick to this is if y is isolated by itself on the left side of the equation, locate the vertex, and from the vertex, shade the side above the vertex if it's greater than or equal to. Shade the side below the vertex if it's less than or equal to. Since this is greater than, we're going to shade above the vertex. So we're going to shade all the ones that are above the vertex. Okay, so as you can see here, the points of intersection, or where these two colors overlap, is actually the solution. So it's this point right here that we consider as the solution to this inequality. So this is the solution for this system of inequality. So if it happens that we have a point that's only on the red, that is a solution to the red only. It is not the solution to the system. Now, if we have a point that is located on the blue, that's only the solution for the parabola and not for the system. So it has to be to both of them. So we go where the two colors overlap or where the two colors intersect. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So first, we are going to show the work down here. So we're going to start with this first one right here with a line. And then I'm going to show the work down here. Again, the first step that we're going to do here is to determine the vertex. So the vertex for this is at positive 4, 7, because to switch and keep. So that's at 4, 7. So I'm going to write the vertex right here, 4, then all the way to 7. So that's the vertex. And then to determine the rest of the points, again, we remember we are going to cover the h and the k, and then we are going to change the inequality to equal sign. So then the working equation that we're going to have would be y is equal to negative x squared. And from the vertex, so we remember that, again, we fill this x with these values 1, 2, and 3 to determine where do we go. So we put in the 1, so that's 1 squared would be 1, but there's a negative in front. So we go ahead and say this is negative 1. That means we are going down. And then this one would be 2 squared would be 4, and then that's a negative. So that's negative 4. So that means we are going down. And then 3, we plug in the 3 here. 3 squared would be 9, and there's a negative in front, so that's a negative 9. That means we are going down. So then we go ahead and graph the dots here. So 1 to the right, then we go down 1, so it's going to be right here. And then 2 to the right from the vertex, 1, 2, and then we go down 4, 1, 2, 3, 4, so it's going to be right here. And then from the vertex, we go 3 to the right, 1, 2, 3, then we go down 9, because that's a negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where the next dot is, and we're going to reflect it across. Okay, so this is the dot. Now we determine if it's a broken line or a solid line. Since there's no bar underneath, we're going to use a broken line. So this is going to be a broken line right here. Okay, now we are going to determine which part do we shade. Is it above the vertex or below the vertex? Again, the trick is if y is isolated by itself on the left side, locate the vertex, and from the vertex, shade the side above the vertex if it's greater than or equal to. Shade the side below the vertex if it's less than or equal to. Since this is greater than, we're going to shade above the vertex. So this side here, that's the vertex. Above means up the vertex, so we're going to shade all the parts above the vertex. Okay, so pretty much the solution is outside of this parabola. Now we are going to change this, since this is a line, we're supposed to change this into y equals mx plus b. It has to be y should be isolated by itself on the left side. So I can go ahead and rewrite this. Okay, so we got this equivalent equation right here. We had to isolate y by itself. So that means the m for this is negative 4 over 3, and then the b is 3. Now we remember the m represents the slope, and this is what it means. So from here, we can go ahead and say that we plot at 3. So I'm going to go up to 3. That's 1, 2, 3. And so it's going to go here. That's 3 right there. And then since this is negative 4 over 3, this means that we go down because it's a negative. So we go down 4 and then 3 to the right. So I go down 4. So 1, 2, 3, 4. And then I go to the right 3. 1, 2, 3. So this is where the next dot is going to sit. And then we are going to determine whether it's solid or a broken line. Since there's no bar underneath, we're going to use a broken line. So we're going to use a broken line right here. Since it is less than, again, the trick is if y is isolated by itself on the left side, locate the vertex, and from the vertex, shade above the vertex if it's greater than or equal to. Shade the side below the vertex if it's less than or equal to. Since this is less than, we're going to shade below the vertex. So I'm going to shade anything below the vertex would be the solution. So then I'm going to shade anything below here. Okay, so we can see that the points of intersection would be this part right here. So this section right here. This is only for the red. This is only for the blue. So it has to be the overlap between the red and the blue. So it's actually this portion right here is a solution to this system of inequalities. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!